Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's hard level difficulty puzzle. And it's called Number Snacks Doubled by Oddly Even. And here are the rules. Normal Sudoku rules apply, which means put the digits 1 to 9 once each in every row. We can get a column here, column and 3 by 3 box. We also have doublers, where one cell in every row, column, and box is a doubler. Oh, box is a doubler. This cell has value equal to double its digit for the following rules. For each of the following rules, which will continue. Actually, it's only two. It's Renban and it's X sum. Interesting. Okay. So one cell in every row, column, and box is a doubler, and the cell has value equal to double its digits for the following rules. And each of the digits 1 to 9 appears exactly once in a doubler cell. So there are no repeats in the doubler cells, is another way of putting it. So that's another constraint you have with doubler cells. And the doubler values are specifically doubled on Renbans and X sums. So we have Renbans where values, not digits, on a purple line form a set of non-repeating consecutive numbers in any order. Oh, that's interesting. So that means you have, again, you cannot have a repeat of values on a Renban. You could have repeats of digits, though. But in specifically this, on a Renban, you cannot have, they form a set of non-repeating consecutive numbers for the values. So that's why you can't have repeat values, but you can have repeat digits on the Renban. So if this value were, say, I don't know, you could have something like 6, 7, 8, 9, and a 5, as long as the 5, well, actually 5 could be doubled or 5 could not be doubled, and that would still work as a Renban, right? As long as these other digits are not doubled. So if this digit was essentially not doubled, you could have 6, 7, 8, 9, 10 as the values of the Renban, and that would work. So if this were doubled, essentially, it would be essentially 10, 9, 8, 7, 6 as the values on this Renban, and that would work. And they can be in any order, right? So again, for the Renbans, the values cannot be repeated. The digits could be. So you could actually have, what could you have here? I'm not sure. Maybe you could have 4, you could have 4 here and 4 here, and this would be doubled. And then you could have 5, 6, 7 in some order. So it could be like 6, 7, 5. So this would work because, again, the values form a set of non-repeating consecutive digits. So we have the values 4, 5, 6, 7, and 8, and that would work. So that's how Renban lines work. We also have X sums, where a number on a Renban line outside the grid, so any of these digits, or not digits, these are not digits. So remember that constraint too, or not constraint. This is actually a expansion of rules. So remember, for normal Sudoku rules, the 1 through 9 constraint is only inside the grid. So outside the grid can be any number, right? You don't have any constraints outside the grid. So for a number on a Renban line, so for any of these numbers, these cells, it could be any combination of any number. It could be just any number, really. The number on the Renban line outside the grid gives the sum of the first x values from that direction, where x is the value next to the number, and x cannot be greater than 9. But I mean, that's given because Actually, we don't know. We didn't know. That's actually a pretty important constraint. So x cannot be greater than 9, right? Because you can never have more than 9 digits. So trying to add the sum of 10 or more digits doesn't make sense in normal Sudoku. Which this is still essentially a normal Sudoku rule. So say this were a 6. This number would have to be the sum of the first 6 values in that column. Same here. This number would have to be the sum of the first 6 numbers in this row. And that's how xsums works. Sorry, first 6 values in the row, right? Because we could have doubler cells. So that's very important to remember. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now I'm going to get started. Let's go. Okay, the one thing that we see is this really long Renban line. That means it's definitely greater than how many numbers does it have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. It has 15 numbers on it. And on top of that, only 3 of the numbers are outside the grid. And we can only have 3 doublers, because they are specifically in box 4, box 5, and box 8 completely. So that means the values outside the Renban must be greater than 9, because again, we can only have the digits we have what, 12 digits? I think 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 digits. We have 12 cells inside the grid. That means the digits 1 through 9 have to appear in those cells. So that means we need the digits 1 through 9. Then we have to have doublers. And if it's a Renban, the numbers must be consecutive. And we have 15 numbers. And we know we need 1 through 9. You can't ever get a 0. So it must be the numbers 1 through 15, which means these are either 11, 13, or 15 as the, what is it called? As the xsums here. These must be 11, 13, or 15 because we need the values on this Renban from 1 to 15, because we know we have 1 through 9. We have the doublers from 5, a doubler from 6, which is 10, 12, and a doubler for 7. So these digits must be 1 through 9, obviously, but we have 2 digits. So, okay, where are the doublers? There have to be 3 doublers on this Renban, because otherwise you won't get values from that are unique. So this has to be a doubler. So the rest of this box cannot be a doubler. The rest of this row cannot be doublers. We know we need a doubler here. So the rest of this box cannot be a doubler. That means where's the doubler in row 4? It must be one of these 3 cells. So none of these can be doublers either. This then has to be a doubler here, which means none of these can be doublers, and this column cannot be a doubler. The doubler then has to be on this line. So we need either 10, 12, or 14. So this will be, the doubler will be 5, 6, or 7 here. This will also be 5, 6, or 7. And we have, it can only add up to 15 at most. So that means this is 1 through 5 for the other digit, but we don't know which one that is. It has to actually be, oh, we don't know. Hold up. We know this is a doubler. It cannot be 5, 6, or 7. So the doubler cannot be on the edge here specifically. So this must be the doubler, which means none of the rest of the row can contain a doubler. This cannot be 6 or 7. I don't think it can even be 5 even. It can't be 1. Oh, that's actually interesting. It can't be 1 because that would add up to 1. It could be 2, but this is a doubler and this has to be an odd digit, so it can't be 2. So it's at least, it's 3. It's, okay, so if this were 2, this would be a doubler, so this would be an even digit. Plus 2 would be an even digit, so the whole sum would be an even digit. That's the reason why it can't be 2, because, again, these sums must be 11, 13, or 15, because those are the only digits, those are the only values which cannot be represented inside the grid. This also must be a 5, 6, or 7. If this were 5, this would have to be at least 6 in value doubled. Actually, if this is 4, this is at least 10 in value. And these two digits would have to sum to 3 at least. So that would be 17, which is not allowed. Therefore, we know this is 3. So this is an even digit. This also must be an even digit to add up to an odd digit. And therefore, this must specifically be 5. This is 10 plus 3 and 2 to add up to 15. So that's the maximum we can have. Therefore, this is 15. This cannot be 15, and this cannot be 15. So one of these is 11. One of these is 13. This 5 cannot be 5. I'm not sure. Anyways, 2 cannot be here. This cannot be 1 here. Also, it can't be the doubler, right? If this is doubler, then that value is going to be greater than 9, which is not allowed. X can't be greater than 9 for the X sum. So this is not a doubler. This could be a doubler. This could be a... This cannot be a doubler. Well, actually, it could be a doubler as long as it's 1 or 4 or 3. This cannot be 1 because it must add up to at least 2. It must add up to at least 11. So this could be 2. It could be 3. One of these 3 is a doubler. So it cannot be 4. If it were 4 with a doubler, that would mean that it's at least 12 plus... Can it actually be 3 then with a doubler? I don't think so, right? It can't be 2 with a doubler because then those would both be even and we'd have the same problem as this X sum here. The 5 does not necessarily... This is 6 or 7 here as a doubler. We also have 6 or 7 here as a doubler. Let's see. It could be something like 2, 9. That's the only possibility for the 2. Can you ever have 4? If you have 4, you would have to include the doubler, and the doubler would add up to 12. 6 doubled at least, which is 12. So that would be 16 already, which is not allowed. So this is specifically 2 and 3. And you cannot have the doubler in either of them because it has to add up to an odd digit. Well, also, if you had 12 and you had 3 digits, so you can't have 2 and 12. That adds up to 14. If you have 3 and 12, that already adds up to 15, which we can't have because we need 11 and 13 left. So this cannot be the doubler. This could be the doubler as long as this is 2 and 9, which is possible. But if it's 3 and this is not the doubler, then that's okay also. So you could have 2 and 9 adding up to 11 here. You could have 3 with like 1 and 9, or 3, 2, and 6. Hmm. Hmm. Let's see. Hmm. Yeah, this is kind of broad here. This again adds up to 11 or 13. It can't be 2. It cannot be 1. This is at least 3. And it could be 4. It can never be 5, though. So this is 3 or 4 here for this x sum. Wait, can it ever be 3? These two have to be in a Ren band together for values. And those values add up to the x sum with 3. To get, actually, could you even get 4? I don't think you can get 4, right? If you have 4, so obviously 5 is out because that adds up to at least 15, even without doublers. 4 digits adding up to 11 would be 1, 2, 3, and 5, but that's not allowed because of the 2 already in the row. 4 digits adding up to 13, and you can't have 1 doubled with another 1, so that doesn't work. 13 for 4 digits would be 13 with 4 digits would have to be 1, 3, 4, and 5. So then this, I think that's possible. So if this is 4, none of these would be doubled. So this would be 1, 3, and 5 here. That adds up to 13, so this would be 11. And this could not be 3 or 5. It would have to be 1 here. This would then be 3 and 5. This would be 4, but you could have the 2 doubled as 4 in value with the 6, so that works. So if this is 4, this would be 1, this would be 3 and 5, this would be 2 doubled to add as the 4, and then you would have to have a 6 here. So that is possible. If you have a 3 here, so that would add up to 13. If you have a 3 here, to add up to 11, this cannot be doubled. Oh, this could be 1 doubled here. This actually could be 1 doubled, and this could be 9, then if that were the case. Oh, that's an interesting little tidbit I didn't see, but yeah. So this could be 1 doubled with 9, and then this would be 876 or some sort. Well, the 1 would be doubled, so none of these could be doubled, so this would have to be 876 then. Huh. Okay, we don't know what that would be then. Or it's 3, adding up to 11 or 15, or sorry, 11 or 13. Well, okay, no, if it's 3, this would have to be 2. And so this would be 2 and 9. This would be 11. So if it's 3, it adds up to 13. So these 2 digits would have to add up to 10. We don't have 2 8s. We don't have 3 7. And 1 9 is too large as a Renban to work. So this would have to be the values 4 and 6, but 3 cannot be doubled because 3 is already in the box. So this would have to be 4 and 6. Then 4 and 6 would have to be 5 with 5 and 7 because 3 can never be doubled. So this would be 7, this would be 5. So that's possible. Huh, interesting. That's a wide variety here. This could be 1 doubled, and this is 9. Either way, okay, so if this is 13, I guess this still could be 3, though, adding up to 11. Oh, you can't have a 3 on this Renban. Right, because it's a Renban. So we need all the digits from 1 through 3. This is a 2. This is a 2, and therefore this is 9, and therefore this is 11. This adds up then to 13. Cannot be 1 doubled anymore here, so this is not doubled. We have a 2, 9 here. Right, because you don't have a 3 in value doubled, so this can't be 3. This therefore has to be 2. It's 2 and 9. This can no longer be 9. This can't be... Okay, so what are the possible combinations again? Either this is 4, we have 3, 5 here. This is 2 doubled, this is 6. And this is 1. Or this is 3 and this is 4, 6. We need a 7 here and a 5 here. So either way, 3 and 4 have to be here, right? It's either 3, 4, and 6 adding up to 10. Or sorry, 3, 4, and 6 adding up to 10 plus 3 is 13. Or it's 4, 3, 5, and 1. Also, the 6 has to be one of these 3 cells. We know the 4 is one of these 3. We know the 3 is one of those 3. We know the 5 has to be one of these 3. Okay. This could be 1 or 3 or 4. We're not sure. This adds up to 11, so that's fine. Either of these could be doubled. That's fine. The remaining digits, or the remaining sums, are 12, 14, 1, 4, 5. But 5 cannot be here. 5 could be any of these, though. It's pretty broad. This cannot be 3, 4. It cannot be 2, 3, 4, or 5. So this is 1, 6, 7, 8, or 9 here. This is 15. These are consecutive, but they're numbers, right? There's no restriction there. How about here? This is at most 9. So therefore, these sums must be at most 9, 10, 9, 10, 11, 12, 13. So these sums are at most 13. There's only 1 double here also, though. So that means 8 and 9, right? Oh, you can't have 10, 12. You can't have 10, 12, or 14 because we already have those 5, 6, and 7 in the doublers. So this value is at most 10 or 11 here. Interesting. Actually, what is this x sum? If you had 4 here, that's at minimum 4 plus 1 plus 6 plus 7, which is 18. And that 18 cannot be on a Renban with a 9. So this can never be 4. This has to be 1, which means this value as a Renban is a 1. So we have 2, 3, 4, and 5 here, specifically. Huh. Interesting. This number cannot be 2, because at least you have, okay, this, to add up to 3, 4, 5, you have to have 2 digits. It can never be 3. So this is always 2 here. This can't be 2. This could be 3 as long as this is 1. If this is 4, so this is not doubled because we don't want a 4. You could have a 1, no, because 1 doubled is 2, so that doesn't work. So this can't be doubled either, right? None of these can be doubled here. If this is 3 in value, this becomes 1. If this is 4, this is 1 doubled, which is possible. If this is 5, this is 3 as a normal digit, but we don't know which. Okay, so if this is 3, this is 1, this is 4, 5. That's fine. If this is 4, this is 1 doubled. This is 3, 5. Okay, so that's fine. If this is 5, this is 2. This becomes 3. This is 4 and 3. So 2 is here. 2 is here. Where is the 2 in column 3? It must be here. So this is 2, which means this is the 2 doubled. So this must be 4 with 1 here, and this is 3 and 5. Right? To add up to 13. These are not doubled. This is not doubled because of the 2. This is not doubled either. These can't be doubled. Since these can't be doubled anymore, this can't be doubled. Where's the doubler in box 4? It must be here. So this is the doubler, which means this can't be doubler. This has to be the doubler, which makes this a 6 or 7 here. We don't know what this is, actually. This 6 or 7 cannot be in the doubler. It has to be. It cannot be anywhere else on this Renban. But we know we need 2 6s and 7s, whichever one this doubled is. So this is a 6 or 7, and this is a 6 or 7. Okay, so now we have a 6 7 6 7 pair in row 6. Therefore, this doubler must be one of these 2 digits, and this is a 6 to be on a Renban with values 3, 4, and 5, because 2 doubled is 3, 4, and 5. This 6 means this can't be 6, therefore this must be 7, which makes this the 6 doubled. This then has to be the 7 doubled. Where is the 6 remaining on this Renban in value? It has to be here. So this is a 6. The remaining values are 3, 4, and 8. This is 4 and 8. And we have 3, 4, and 8 here. One of these is a 3. We're not sure which. Let's see. 2 can, okay, so this is 1 in value. The remaining digits in column 5 are 4, 6, 7, 8, and 9. But 7 cannot be any of these 3. This can't be 6. This can't be 9. The remaining digits in row... Oh, that's interesting. The remaining digits in row... 7 have to be 6 through 9. And this can't be a doubler because that would be... X would be greater than 9 in value. Therefore, the doubler is one of these 2. This also has to be... This sum is... These sums are consecutive in value. Huh. That's interesting. What does that mean? Obviously, this could be 45. This can't be 6 here. We have 4, 7, 8, 9 remaining in box 8. This cannot be 1, 2. It could be 3, 5, 7, 8, or 9. Where is the 6 actually in column 2? Can't be any of these because of this 6. Can't be any of these because of this 6. So it must be here. So this is 6. The remaining digits in box 7 are 1, 7, 8, 9. But this can't be 9 here because of the 9 in the column. Where can the 7 be actually in column 2? Can't be any of these because of the 7. Can't be here because it's the X sum. So it must be one of these two cells. So this is a 7, which means these can't be 7 here. 6 has to be one of these 3. Whoops. One of these 3 is 6. What is the sum of this already, actually? This is at least 6 digits. And the 7 or 8 is doubled. 7, 8, or 9 is... Actually, 8 or 9 is doubled. Huh. Okay. This cannot be 3 because it sees one of the 3s on this red band. It can't be 2, 4, 6, 2, 6, 7, or 9. So it could be 1, no 3, could be 4, 5, or 8. Okay. Okay. Yeah, let's add up what this has to be as an X sum. If it's 6, it's at least 8 doubled. So it'd be 45 minus 12. 45 minus 12 is 33, plus 8 doubled is at least 41. So this has to be at least 42 or 40. Yeah, so 6 is the minimum here. The minimum with the 8 doubled, because we know one of these is doubled, and it's either 8 or 9. So if we had 8 doubled at minimum, we have 45 minus 12, that's 33, plus another 8 for the 8 doubled, that's 41. That means the minimum value for this sum must be 40. But if you take just the first 8 digits here, that only adds up to 39, because we have 45 minus 6 here, which would be 39. Therefore, this must always be 9 digits for the X sum. And this can't be 9. So this is 9. That means this adds up to exactly 45 plus 6, which is 51. That means this sum must be 50 or 52. So 6 doesn't work anymore because the maximum would be 45 minus 12, which is 33, plus 9, which is 42. We need 52 or 50. So can it be 8? If we have an 8 here, the 9 is doubled. Right? So we have 8 digits. That's 45 minus 4. So we know, okay, so we know this is specifically 51, right? Because it's 41 plus 6, because the 6 is doubled. So that's 51. This has to be at least 50. I think 8 with 9 doubled, 8 digits, so it's 45 minus 4. It's right. If we have 8 doubled, sorry, if we have 8 values added, you have 45 minus 4, which is 41. You have the 9 doubled, so you add 9. That's exactly 50, which is the minimum that we need. And this is the maximum value then. So this is 8, which means this can't be 8 or 9. The 9 has to be doubled. This has to be a 6-9 pair. We're not sure which one's doubled, though. Therefore, this can't be 8 or 9. This has to be 7. So this can't be 7 here. One of these is a 9 doubled. We have a 9 here. This 6 cannot be doubled because we already have a 6 that's doubled. So this is not doubled here. Oh, where is the doubler in column 2 now? Can't be here, can't be here, can't be any of these because we already have a doubler in the box. So this has to be doubled, which means this has to be 1 doubled, and this makes this a 4, which makes this a 3-5 pair. That eliminates these 3 and 5 are distinctly different, unique values, and therefore distinct digits because they don't double. None of these are doubled. None of these are doubled. These both see these 2 cells, so it cannot be 3 or 5. It has to be 7, 8, or 9. Interesting. Huh. If this were a 9, that means this would add up to 51, and this would have to be 50 or 52, which would mean that it would have to include a 5 or a 7 doubled here to add up to 50 or 52. But we already have the 5 and 7 doubled, so this can never be 9. It's 7 or 8 here, then. This digit also sees 3 and 5 distinctly. It cannot be 1, 2, or 6. This could be 4, 8, or 9 here. We're not sure which. Where is the 1 actually in? This can't be 1 because of the 1 here. This becomes a 7, 8 pair, which eliminates 7 and 8 from the rest of the box. This can't be 8. This is a 1, 9 pair. This can't be 1 or 8, so this is 4 or 5 here. Where is the 1 in column 3? Can't be any of these cells because of the 1 there. Can't be here. Can't be any of these 2. It must be here. So this is a 1. We have a 3, 5, 3, 5 pair in column 3, which eliminates 3 and 5 from the rest of the column. This cannot be 3. This can't be 3 or 5. This is 4, 8, or 9. Well, this 4, 8 and this 4, 8 are on the same Renban and are the same and are not doubled. Therefore, they must be different digits. So therefore, this 4, 8 pair eliminates that from being a 4, 8. So this must be a 3. Let's see. This can't be 3 or 5 because it sees both 3s and 5s. It can't be 1, can't be 6, 7. So no 1, could be 2, could be 4, no 3, 5, no 6, 7, it's 8 or 9 also is a possibility. This is 1, this is 1, 4, we don't know what this is. This is 7 or 8, that's a large number. We might have to go through the possibilities here. Let's see. 9 in box 8 has to be one of these 2 digits. Therefore, 9 cannot be here. 9 has to be one of these 2 digits then in box 5 because it can't be here, can't be here, and it can't be here. None of these could be 9, so one of these is a 9. Doesn't really tell us much. 9 has to be one of these 2. The remaining digits here are 3, 4, Ah, 4 cannot be here. So where's the 4 in box 1? It has to be one of these two digits, which means this is a 4-9 pair here. Because 9 also has to be there. Well, that means this 4-9 pair eliminates 4 and 9 from the rest of the column. Therefore, this is an 8, which makes this a 4. These can't be 4. This becomes an 8-9 pair. This 8 means this can't be 8 here. The remaining digits here are 3, 4, and 5. The remaining digits here are 3, 4, and 5, and one of these is a 3. This can't be 4, though. And one of these two is a 4. This is a 3, 5, 7, 8 possibility. 3's here, 3's here. The remaining digits in row 5 are 1, 3, 4, 5, 6. But this can't be 3. Any of these could be 3, though. Okay. If this is 7 here, that means it's 45 minus 10 because of the 1-9 pair here. So that's 35 plus 6, which would be 41. Okay, so that is possible. If it's 8, then it's 42. So this is 41, 42, or it would be 50. Okay, that's interesting. What are the remaining digits in row 6? We have 1, 2, 4, 5, 8. Right? This can't be 8 because of this 8. It's one of these 3. This is at most 5 and 6 here. That's actually interesting. So this would have to be the values 5 and 6 if that were the case. I don't think 9 can ever be on this Renman, right? If you have 9, you have to have an 8 in value. I guess you could have 4 doubled there. That's possible. We also have 3, 4, 8, and 9 doubled. 8 cannot be the doubled here. So 8 is either doubled here or doubled in one of these two. We have a 9 doubled here. We have the remaining digits now that are doubled are 3, 4, and 8. This can't be 6 here because of this 6. 4 is one of those two. It's fine. So this is either 41, 42, or 51. Or, no, sorry, 50. The remaining digits in column 6 are 1 through 6, but this can't be 1 here. This can't be 6 here. This can't be 1 here. So one of these two is a 1. Doesn't really help us much. This can't be 3, actually. Oh, this 3 means this can't be 3, so therefore this is 5, which makes that a 3. That's actually helpful. This can't be 3. We have a 5. This 3 means this can't be 3, so this is 5, which makes that a 3, which means this can't be 3. Where is the 3 in box 4? It must be here. So this is 3. 3 has to be one of these 3 cells. We're not sure which, though. 3 cannot be here. 3 cannot be here either, actually. Because of this 3. These can't be 5 anymore. So the 5 has to be one of these 3 cells here. The 3 is one of these 2. This is either 4 or 8 being doubled here. This is 3 or 4 being doubled here. And then we have 3, 4, 8 here. This can't be 2 because of the 2 here. Again, I don't think you can ever have... you could have 4 doubled there. The remaining digits... Okay, this can't be 4. The remaining digits in column 4 are 2, 8, and 9. And those all are satisfied there. So if this is 7 here, that means it's 45 minus 10, which is 35, plus 6, which is 41. So then this becomes 40 or 42 with 7 digits. I guess you could have the 8 doubled. Okay, so if you have 7 here, you could have the 8 doubled here. Specifically. That's the max you could have, right? So then what's the max here? It would be 7 plus 2 plus 9 plus 5 plus 1 plus 6 plus 8 doubled. So I think that would leave 3 and 4 here. So 8 plus 7 plus 8 doubled. Okay, let's just go in order. 7 plus 2 is 9. 7 and 2 is 9. Plus 9 is 18. Plus 5 is 23. Plus 1 is 24. Plus 6 is 30. Plus 8 doubled is 46. So you could actually have up to 46 as a maximum. The question is, how do you get to 40 or 42? I don't think it's that hard, actually, thinking about it. Okay, so you always have 7, 2, 5, and 1 there, right? So that would be 15. So you need at least 25 in 3 digits. Or 27 in 3 digits, either way. Okay. Right, because if this is 41, again, this is 42 or 40. You have 7, 2, and 1 with 5, definitely guaranteed. So you have 3 values adding up to 25 or 27. 25. I think you can't have a 4 and a 6. If you have 4 and 6, that's 10. Right, that doesn't work. It adds up to 15 or 17 again. Okay, so, right, because you have 15, sorry, 25 or 27. 27 would be difficult. You have 9, 6, but 8 double doesn't work. I guess you could have, no, 4 double doesn't work either. 3 double doesn't work. What about 9, 4, and 8 doubled? Right, because you need an odd digit somewhere. And if the 3 and the 4, well, Either way, I think that means that the doubler cannot be in the end. If this is, I guess this could be 42. Yeah, I think that means that the doubler can never be the last digit. No, you could have 3 doubled as the last digit to add up to 42. And that, or 44 doubled as the last digit, which adds up to 41, which we could go with 42. That's possible. Okay, never mind. Can you ever add up to 40 or 42 with 7 digits, 7 numbers, and one of them being doubled? So again, 25 or 27, that means something has to be doubled. You cannot have 3 or 4 doubled. I guess you could have 4 doubled with 8. 4 doubled is 8, plus 8 is 16, plus 9, right? So it would be 4 doubled with 9, with the 8. So this would then be 4 doubled, this would be 9, this would be 8, and that could work. Okay. These digits cannot be 1, 3, it could be 2, 4, 5, 6, or 7. So one of these 3 is a 7 here. 9 cannot be here. Well, we already knew that. Okay, so 8, we don't know. So we have a 6 in value, an 8 in value, a 16 in value for the doublers. So again, you could have 4 doubled, 8, and 9, and that adds up to 25. So therefore, 7 does work, as long as this is 8. So 8 does have to be either here or here. We're not sure which. This would be 4 doubled, so this would be 9. And this would be then 3 and 6 here. Yeah, it's possible. So this would be 4 doubled here in that instance. Otherwise, it could be 8 doubled, or not 8 doubled, 8 for the x sum. And like we said, it could be 42 here, which would make that 1. This could be 8, adding up to 41. So the 4 would be doubled here, and then these 3 would be plain. So that would be 4. Either way, that would be 9. Can this ever be 4 is kind of the question, right? If you have 8, you could also add up to 50? Yeah. You could also have the 3 being doubled, right? What are the possible values, adding those up? We know 9 can never be on this renban because it requires an... Well, actually, it could be, as long as this is the 4 doubled. Hmm. This is 1 through 7 here, but no 6. This can't be 6 either. Uh, 1, 2, 3, 4, 5, 7, 8. 8 could be here. 8 is one of these 2 digits. The remaining digits in row 1 are 3, 4, 6, 7, 8, 9, but this cannot be 8 or 9. Hmm. Uh... Hmm. Okay, so we've already done 47 here. The question is, what if this is... Okay, this can't be 8 here. We know that for certain then. If it's 8, that's kind of a question, right? So if this is not... So though so far... Well, we don't know anything about this, actually. If this is 8, this could be 42. This could be very well 41. It cannot be 43 in that instance. So if this is 41, this could be 40. Right? Actually, it could be 40 or 42. 6... 6 and 9 add up to 15. Oh, plus 16. That doesn't work. Oh, wait. 4, right. It's 4 doubled, not 8 doubled. Right. Right. So this would be 40 in that instance. If this is 42, this cannot be 43. I don't think. Maybe it could be 43. It could definitely be 41. Okay, so it could be 41 here because this could be 4 at the end doubled, and that would be fine. And then you add up everything else, which would be 45 minus 4, which is 41. Cannot be 42. Could it be 43? If you... So 45, add 3 more, 48. Well, you can't have a 5 there. So you would have to have the 4 doubled again. You would have to have the 4 doubled again. Um, hmm. If you had the 4 doubled, that makes the total sum 45 plus 4, which is 49. You could subtract out a 6, and that could work to add up to 43. So this could also be 43. Okay, lovely. So that works also. That's pretty broad. Uh, hmm. Okay. Remaining digits in row 8. It has to be 2 and 3. And we cannot have 2, 3, could have a 1. No 6, 8, or 9, so this is 1 or 7 here. And this is 4, 5 with 1 or 7 also here. Okay. Still pretty broad. Let's see. Even if we tried this as 50, okay, so 49 or 51. Okay. I don't think that's possible, actually. 51's not possible. If we have 51, the 8 could be doubled. So that's 45 plus 8, which is 53. But you always subtract at least 3. Oh, interesting. All the combinations I'm getting, 4 has to be one of these digits here, which makes this a 9. That's actually very interesting. Right, because even when we add, this was 41 and this is 40, this would be 4 doubled, so this is 9. We have an 8 normally, and that works. If this is 42, could be 41 or 43. For the 41, we have the 4 doubled here, because it subtracts out that. I guess you could also have... Could you have the 8 doubled? If you have 8 doubled, that's 53. You need to subtract out 10 or 12. So no, you can't have the 8 doubled. And if you have the 4 doubled, that makes it 49. I guess you could have a 6 here, but then that would still be the 4 doubled. Could you ever have the 3 doubled is kind of the question, right? If you have the 3 doubled, 45 plus 3 is 48. To get to 41, you could have the 7 here. So you could actually have the 3 doubled here. Can you ever have the 8 doubled is kind of the question here, right? Obviously it doesn't work with the 7 because it's too much. But to add up to the 50 or it would have to be 49 or 51. Obviously you would add up. You could have the 8 doubled. Oh, you can't have the 8 doubled because the 8 would be here. So I think the answer is no, you can never have the 8 doubled here. Which means the 8 doubled has to either be here or one of these two digits. Huh. Because it cannot be on the run band, because that would be 16 on the run band, and it's too large. Hmm. Right, so if you have 8, so if the only way you could have 8 doubled in this row would be is if 7 were here, because the 8 would have to be doubled here, but then that would be too big, right? You would need 2 digits, so you would have 4 digits adding up to 15, plus 8 doubled, so that's 16, 31, and you would have 2 digits that would have to add up to 40 or 42 with the 31. So that would add up to 9 or 11. And these combinations don't work, right? You have to have 9 or 11, so it's 2, 7, but you can't have a 2. It's 3, 6, but this can't be 3 or 6. 3, you already have the 8 doubled. So yeah, you can't have an 8 doubled in row 1. So the 8 doubled is either in row 3 or row 4, but we're not sure which one it is. Oh. because of that, either this is the 8 doubled or one of these two is the 8 doubled. So that means one of these 3 cells is a doubler in columns 7 and 8. Well, that eliminates doublers in the rest of column 7 or 8, so this cannot be a doubler, and this cannot be a doubler. So if that's the doubler, then this must be the doubler. So the doubler in row 1 has to be either 6 or not, but we already kind of knew that, so that doesn't really help too much. It's one of these 3. If it's here, that means this is a doubler, and that has to be a doubler. That's interesting. If it's one of these 2, that means one of these 2 is a doubler, which is fine. So where is the 8 doubler? Either the 8 is here and doubled, or the 8 is here and doubled. Either way, they all see this cell, so this can never be 8, but that doesn't really satisfy anything, right? This could still be 8 here, which makes that an 8 doubler, which is fine. Oh, interesting. If this is the doubler, it's 4 doubled. It definitely has to be 4 doubled there. Oh, but does that work? So again, if this is the 8 doubler, that would mean this is not the doubler, so this is the 9 doubler here. This can't be the doubler there and there, so this must be the doubler. It cannot be 3, cannot be 8, so it must be 4 doubled. Which means this cannot contain 4 doubled. 8 is also here, so 8 cannot be here, so this must be 8. This can't be 4. This is 4 doubled here, which means that would be 8. So it would have to have, it could not have 9. Oh wait, it could be 9. My bad, I forgot. This actually could be 9 because of, right, this 4 being doubled, exactly what I was saying. So, but we need 5, 6, and 7. So this, since this is 4 doubled, this would have to be 5, 6 then. Because that's the only combination that could work for the 7. Oh, actually, I guess it could be, no, it can't be 4. That's right, that's the reason why. So 4 doubled cannot go with 3 for 5 unique values. 3, 4, 5, 6, 7 is the max there. So if you have 8, you have to have 5 and 6 here because this is 4 doubled. This then must be 7, and you could have a 4 here or a 9 here. That's interesting. Oh, but interesting. If this is 4 doubled, this is 5, 6, this has to be 4, right? So this is all with this 8 being doubled. If this is 8 doubled here, this is 9, and this is 6, or whatever. So the 4 would have to be doubled here. That would mean this is 5 and 6 to add to be in the red band with the 4 doubled. Which means this can't be 6. This has to be 4, which makes this an 8. And if the 8 is here, this also still has to be an 8 because 8 can't be here anymore. So either way, this is always 8. All right, because if the 8 is being doubled, that's what you're saying if 8 is doubled here. If 8 is doubled here, then this is always 8. So this is always 8 no matter what, which means this can't be 8. These can't be 8. 8 does have to be one of these two digits. Where is the 8 in column 4? It has to be one of these two digits, which means it cannot be here. This is kind of convoluted, which is why this is a hard puzzle. I'm going to pause. I need to go to the bathroom right now. Let me pause. Okay, and I'm back. Let's continue with this solve. Let's see. Okay, where were we? We were trying to figure out what these combinations were, right? 8 has to be one of these two. 8 cannot be doubled here. So 8 has to be either here, which would mean this could not be doubled. So this would have to be doubled here. Or this is 8 doubled here, and 8 cannot be here. We know 8 has to be one of these two digits. This is 8. Okay. So again, if this is 8 doubled, that means this has to be one of the doubler here, means this can't be doubled, so this is the 9 doubled, which would mean the doubler in this row could not be these two cells, so it would have to be here. And the only remaining ones are 3, 4, and 8, possibly doubled. So if this were 8, this would be 4 doubled. You would have to have 5 and 6 here. You would have to have 7 and 4 or 7 and 9 here. Because you would have 5, 6, and 8 in value. You need a 7, so one of these would be 7, and then you would have to have a 4 in value or a 9 in value. So neither of these would be doubled if that were the case. That's if that's 8. If this is 8, obviously these can't be 8. So either way, this would be 4 doubled. This would be 5, 6, which would force this to be 4, which would force that to be 8. If this is 8 doubled, obviously this is not doubled. We know one of these two is 8. Interesting. Okay. If this is 7, so this is not 8, right? If this is 7, this has to be an 8 here, which means this can't be 8, this can't be 8. This would have to be the 8 doubled, which would mean this is not doubled, so this would be the 9 doubled here. This would be 8 doubled, this would be 4 doubled. Well, the doubler could not be here or here or here, so this would have to be doubled here, which would make this the 3 doubled. That means it's 6 in value. 8 would be here. So 8 could not be anywhere here because you have the 8 doubled here. You have the 6 in value, so it's at most 3, 4, 5, 6, 7. But it could be 2, 3, 4, 5, 6. Either way, you need a 3. So you would need a 3 here. Huh. So you would need a 3 in value. So this would be 3. This would be a 3 doubled. You would need 4 and 5. Hmm. Seems very feasible. Hmm. Not necessarily. This could be 4 here, and this could be 4. There's just a lot of possibility here. This cannot be 1, 3. It could be 2, 4, 5, 6, or 7 here. It's kind of broad. Do we have any other restrictions? I don't think so. Yeah. Okay. So this is satisfied. This is satisfied. This is satisfied. We have 1, 2, 3, 4. Wait, we don't have 5 in value here. We have 3 twice. Okay, well, that's one problem. This cannot be 3. Okay, this is... Oh. We're gonna have to go back a lot. Oof. That's rough. Okay. This all logic is still the same. I just messed up the 3 here. Okay, good thing I was checking that because I was like running into problems here. Okay. Let's restart with a clean slate, but knowing the knowledge here. So let's keep the time. This still has to be the same. This has... Okay, so one of these is the doubler. We need 3 doublers here. So this can't be doubler. This can't be doubler. These can't be doubler. Which means these can't be doubler. Oof. That was a pretty bad mistake. We need a doubler here, so this can't be doubler. Therefore, this can't be doubler. Same logic here. Can't be 2 and doubler, because then that would be an even number. So it has to be 3 and doubler, which makes this 5, which makes that a 2. This is not a doubler here, because you can't have a doubler having x be 10 or more. So this is 15 here. Right, I even had that. Anyways, this can't be 3, so this has to be 2, because otherwise it would include the doubler, and therefore it'd be much greater than 13. So this has to be 2 and 9, and neither of these are doubled. Because it has to be an odd value, so this must be an odd value with a 2. Therefore, this is 11. This has to be 13 in value. Okay, I don't remember this part. This cannot be 1 doubled with a 9, because then that would be 2 value, but that would be 11, but the problem is the 9 can't be here. And this has to be 13 anyways. We tried this with... Right, we were figuring this out. This has to be... It cannot be 4, because that's already... this has to be at most a 9 here. Which means... And we only have 1 doubler here, so this would be 8 and 9, which would mean this sum would be 12 at most. If we had 4 here, that would be at least 1, 4, 6, and 7, which adds up to 18, which can never be there. So this must be 1 and 1. This has to be 2, 3, 4, 5. But this is 3, 4, 5. So these has to be 2 digits adding up because it can't be 1. And it can't be 3 digits because that adds up to a minimum of 1, 2, and 3, which is 6. So this is 2. This is 3, 4, 5. These are 3, 4, and 5. This is 1 or 3. This is 3 or 4. If it's 3, this has to be 4 and 6, adding up to 13. And therefore, it needs to be 5 and 7. So this is 7 and 5, if that's the case. Or, well, okay, we know we need a 2 somewhere here. And if this is 4, it could be 3, 5, right? You can never have the 2 with a 4, 6 pair. And it can't be 3, 7, 2, 8, and 1, 9 doesn't work because 1 and 9 can never be on a Ren band that's 4 in length with each other. So 4 and 6, which require, this is 3, but we don't have access to the 3 in value on this Ren band. So it can never be, and it's 4 and 6. 6 can never go down to 2 with a 4 length Ren band in value. We already have the 4 in value here, so the 2 can't be doubled on here, so that doesn't work. Therefore, this can't be 3, 4, 6. It must be specifically 4. This can't be 3 or 5. This has to be 1, which makes this 3 and 5. These are all non-doubled. So one of these has to be doubled. Obviously, this can't be doubled because then that value would be greater than 9. This is 3 and 5. We need a 4 in value, so it must have 2 doubled. And the doubler cannot be here. So we can't have doublers here. We can't have doublers here. So therefore, this must be a doubler here and must be 2. So we have 3, 4, 5. In value, we need a 2 or 6, but the 2 is already taken, and then we can't double the 1. So this must be 6. This can't be the doubler. Actually, none of these can be doubled. This can't be doubled here because we have a doubler already in the column, and this can't be doubled. So where's a doubler in box 4? It must be here, which means this can't be the doubler. This must be a doubler here. Where this value is, whatever this value is, it has to have another 1 on the Ren band line and not doubled. So if this is 6 or 7, where can it be on the Ren band? Can't be any of these because it sees it by normal Sudoku. Can't be here, and these are filled out. So this can, and this is doubled, so it can't be that one. So this must be the same as this. And this can't be 6, this must be 7, which forces this to be the 7. This is the 6 doubled. We need another 6 on this Ren band. It cannot be here, so it must be here. And the remaining digits, which I messed up on, are 4, 5, and 8, not 3, 4, and 8. You probably actually were yelling at me for doing that. So this is 4, 5, and 8. This is 4 and 8. Because we have 1, 2, 3. We need a 4 in value. We don't have it. We need a 5 in value, so it has to be one of these two. And we have a 6 here. We have a 7. We need an 8 in value. We have a 9. We have a 10 in value from the 5 doubled. We have 11 here. We have a 12 doubled, 12 in value here from the 6 doubled. 13, 14 from value from the 7 doubled, and then 15. Ugh, that was a pretty major mistake. Apologies for that. One of these is 8. Actually, where is the 6? Actually, where is the double? This can't be doubled in... and we need a 6 in column 2. And it can't be any of these because of the 6's in the box. Can't be here because this can't add up to 3, 4, 5. So it must be here. And the 6 cannot be doubled because we already have a 6 that's being doubled. So this must be doubled, which makes this a 1 doubled to add up to 4, because 3 doubled would add up to 8, and that's not allowed. So this becomes a 3, 5 pair here for the Ren band. to add up to have the values be consecutive? Well, we have a 3, 5, 3, 5 pair in column 3, which eliminates 3 and 5 from the rest of the column. Therefore, that makes us 4 and 8. We need a 5 in value. Okay, so that's where I made the mistake. So this is 5, which means this can't be 5. This is 3, which makes that a 5, which makes that 3, which makes that a 5. What are the remaining digits in column 2? Actually, in box 7. It's 1, 7, 8, 9, but 1 and 9 cannot be here. Therefore, this is 7, 8. This is 1 and 9. The remaining digits here are 3 and 4. Where is the 5 in column 1? Can't be any of these cells because of that 5. Therefore, and it can't be any of these cells and the filled-in cells, so it must be 5 here, which leaves this as 3, 7, 8. Okay, that's interesting. This can't be 3 because of that 3. We have 6, 7, 8, and 9 here, so this logic still is the same. This, I think, was... So this had to be 9, if I remember correctly, because without this, it didn't add up correctly. So this was 9, and this was 51. And therefore, this was 8, and it was the maximum was if this... so this can't be 6 here. This can't be 8. The 9 has to be doubled here. So the 9 is here, which means this can't be 9. This is 7. This can't be 7 here. This is 4, 8, and 9. Oops. This 3, 4 pair eliminates 3 and 4 from the rest of the box. So therefore, this can't be 4. This is 8, which forces this to be 4, which makes this an 8, 9 pair. So that's the same. This 8 was adding up to 50 because we have the 9 doubled. So it's 45 plus 9. That's 54 minus 4, which makes 50. It's 51. Okay. Remaining digits here are still 2, 8, and 9. This has to be 4, 9, 4, 9. Remaining digits here are 4, 6, 7, 8, and 9 in column 5. So this can't be 7. This can't be 8 or 9. This can't be 9 or 6. We know 1 has to be one of these 3, and 3 has to be one of these 3. 5 has to be somewhere here. This has to be a 1, because there's no other place for it in column 3, so this can't be 1 here. Okay, this is quite different. So this sum, so now we have to recalculate this sum. Okay, these cannot be doubled. This is 1 through 6 here. But this cannot be 1 or 3 here. This can't be 2. Ooh, that's interesting. This can't be 1 or 5. So where is the 3 doubled? It either has to be here or here. What value is doubled here? You can't have the 9. You can't have 1, 2, 5, 6, or 7. Therefore, the 4 has to be one of these digits and must be doubled. Because there's only... 8 cannot be here doubled, or 3 cannot be here doubled. So this is specifically 4 doubled, which means 4 cannot be in the rest of this column and the same box, right? So 4 has to be one of these 2. Oops. 4 is one of these 2. Which means this can't be 5 because of the 5 here. 4 has to be in box 3, one of these cells. Now, this is interesting. Actually, this changes a lot. 4 can never be here. How are you having a Renban this way? This is cannot be 1, 2, 3, cannot be 8 or 9. This is 4, 5, 6, or 7 here. This is 4 through 9. Can this ever be 7 is kind of the question, right? Because we had it with 1, 2, and 3. If this is 7, this must be 45 minus 10, which is 35, plus 6, which is 41. So this is 40 or 42 again. But if this is 7, this only adds up to 1, 2, 3, and 7. 1, 2, 3, and 7. Which is 13. So again, if this is 40, this has to be 41 if this is 7. You have a doubler here, right? Because 40 minus 13 is at least 27. 27, you might be able to get 8 doubled. 8 doubled with a 9 and a 4? That's 13. That's 29. What if you had only the 4 doubled, though? So if you have 7, 1, 2, 3. So we tried 8 doubled. And we had 9 and 4 or 9 and 6 to add up to an odd digit. So this is, again, 13 plus 16, 29. So we need 11 or 13. I guess it could be 4 and 9 here. That could work. Okay. So 8 doubled with 4 and 9 here. Right, so that would be 13 plus 16 plus 13, which would be 42. So that could actually satisfy that. So this could be 42 if that were the case. So this would be 9, this would be 4. This would be the 8 doubled in that instance. So 8, again, would still have to be actually in one of these two spots, which means this can't be 8 here. Can this ever be 4 doubled is kind of the question, right? Well, we can't have it 4 doubled here with this being 7. But if this is 8, maybe, right? We just can't, yeah, we can't have it 4 being doubled here for 7. If we have this being 8, though, this is either 4, it's 41 plus 1, which is 42, or 50 here. So this could be 41 here. If this is 4 doubled, that's 49. So again, this could be 4. If this is 50, and you try to have a 4 doubled here, this would be at most 49. So that 50 doesn't work. What about 42 then? If this is 42, this would be 4 doubled, so this would add up to 49 total. You could have a 6 here, which would make that 43. Yeah, that could work. You can't have anything else, but that would be fine. For that 4 to be doubled. I think either way, this has to be 9. I don't think this can ever be 4 here, right? Oh, maybe. Hold up. If this is 8, you could have 4. You would have to have the 8 doubled. Oh, that doesn't work. Okay. So if we try to make this 4, you can't have 7 again, because that doesn't add up to enough with, so therefore this must be 8. But the 8 and the 4 can't be doubled anymore in this column. So this can never be 4. This has to be 9, which makes this a 4. This cannot be 4 here, which means this has to be a 4, and it has to be doubled. Oh, that's interesting. So this is not doubled here. Because this is the, like, you can't have, in this box, you need to have one of them doubled. The only one that can be doubled is the 4 in this column. So this is the 4 doubled. Which means this cannot be 7. This has to be 8. This cannot be 50 again, because if this is 50, this is at most 49, but we only count 8 digits, so we have to subtract that. So this has to be 42. So that makes this a 1. This is a 9. That makes this an 8, which makes that a 9. This 8 can't be an 8 here, so this is 7. This is 8. These can't be 8 anymore. So this adds up to 42, because the 6 is doubled. We have 45 minus 9, which is 36, plus another 6 is 42. This can be 43. It can't be 41, because we would have to subtract out 8. And this can't be 8 anymore. These can't be 9. So we have to subtract out a 6 here, which makes this a 5-7 pair, and none of these are doubled. Okay. This is a 4 doubled. One of these is a doubled, and it's 3 or 8. But we're not sure which one is which. Remaining digits here cannot be 1. It could be 2, 3, or 4. Cannot be 5, 6, or 7 because of the 5-7 pair here. We need a 5 in value along this Renban. There's not... You can only have double 8, which is not allowed on the Renban. Or you are allowed... Okay, so... one of these 2 digits is doubled. Therefore, it must be a 3 that's doubled here. Okay. Right, because 8 cannot be doubled here. 4, and we have all the other digits. 1, 2, 4, 5, 6, 7, and 9. So this must be specifically 3 doubled as one of these. So one of these is 3. So it's a 6 in value. You cannot get to 10 because we don't have 5 doubled available. So therefore, we need a 5 here. 5 cannot be here. 5 cannot be here. 5 has to be one of these 2 digits. So this can't be 5. This can't be 5. 5 can't be here. Oh, none of these could be 5. Where is the 5 in column 6? It has to be here. So this is 5. What else do we have? 7 must be one of these 3 digits here. So we have a 3 doubled in value. That's 6. It could be 5, 6, 7, 8, and 9. That's... Except the 4 can't be doubled anymore. So it cannot go up to 8. Because 8 cannot... I mean, sorry, can't be 9. Because both 8 and 9... 9 would have to be here. 8 can no longer be here. This is... Actually, this can't even be 2. So this is what? 1, 3, 4, 5, 6. 5 has to be on the Renban. 8 cannot be here, any of these. So if there's an 8, it would have to be here. 9 also cannot be any of these. So not, if there's a 9, it would have to be here. Therefore, we need a 4 in value on this Renban. Because you can't get to 9. So it's 4 through 8 at most. 4 cannot be here. 4 then has to be one of these 3 digits to form a correct Renban. So this can no longer be 4. This can no longer be 4. This can't be 6 either. What are the possibilities? This is 1, 2, 3, 4, and 8. But 4 cannot be here because 4 needs to be on this Renban. This can't be... You cannot have a 6 on this Renban either. Because if you have a 6 on this Renban, that would double the 3 doubled. So that would be a repeat of the 3 doubled, which is 6 in value. You have a 6, so you could never have a 1 on this Renban. That means one of these 3 is 1. 1 cannot be on this Renban, again, because of the 3. Where is the 1 then in box 3? Can't be on the Renban, because it's only 5 in value, 5 in length. So it can't be 1, 2, 3, 4, 5, 6, because that's 6 values. So the 1 has to be here, which means these can't be 1. Where is the 1 in box 6? Can't be here, can't be here, can't be on the Renban. It has to be here. So this is 1. 1 and 1. This is not doubled. One of these is doubled. 8 cannot be doubled on the Renban, because that would be 16, and that's too high. So this has to be not doubled, which means this is doubled and is a 3. This can no longer be doubled. This could be 4 or 5. This can't be 3. This can't, still could be 7 actually here. And the 8 is one of these that are doubled. So since one of these is 8, 8 can no longer be in the rest of the row because we need an 8 doubled here. So this must be an 8. Actually, that's all the same. This can't be 8. This can't be 1. Now we have a 2, 3, 2, 3 pair in row 6, which eliminates 2 and 3 in the rest of the row. This can't be 3. This must be 4, which makes this a 3. This can't be 3 here. 3 can still be one of these. Where's the 1, though? 1 can't be here, 1 can't be here, and 1 can't be here. This must be a 1. Where is the 3 in column 6, then? It has to be here. So this is 3, this is 2. This is 3 doubled. This can't be 3, so this is 7, which makes that a 3. That means this can't be 7. Where is the 7 in box 2? Can't be here, can't be here, can't be here. It must be here. So this is 7. Remaining digits in row 8 are 2, 3, and 7. This can't be 2. This can't be 3. Remaining digits in row 9 are 1, 4, and 5, but these can't be 1, so this is a 4, 5 pair, which makes this a 1. This cannot be 5. Where's the 5 in column 9? Can't be here, can't be here because of this 5. Can't be here, so this must be a 5 here. We know the 4 is one of these 2. This is 2, 4, or 7. 2 could be, 2 cannot be here though, because of this 2. We know 4 has to be one of these 2 digits. These can't be 6. The remaining digits here are 2, 8, and 9. 9 cannot be here because, again, we can't have 9 with the 6 in value but not having an 8 available. So this is either 2 or 8. Therefore, 9 has to be one of these 2 cells in row 3. Therefore, this can't be 9. Also, 8 has to be one of these 2 cells in column 4. So 8 cannot be in the rest of box 2. So therefore, this can't be 8. This is 9. which means this can't be 9. This becomes a 2, 8 pair in column 4 and box 2, which eliminates 2 and 8 in the rest of the column and box. So this can't be 2, this is 9. This can't be 2, this is 6, which makes this a 2. This can't be 9 then. It's a 4, 6 pair here. These digits are 2, 4, 8, and 9. These digits can be remaining are 4, 6, 7, 8. But 4 can't be here because one of these two digits must be a 4. But it could be 3, 4, 2 here. Well, what does that mean? If this is 2, that means it has to be 3, 4, 5, 6, right, to form the Renban. The problem, though, is if this is 2, this becomes 3, which makes this 4. And this 2 and 4 would eliminate all possibilities for that cell. So this cannot be 2. This must be 8, which makes this 2, which makes that 8. None of these can be 8. This can't be 8 anymore, and is therefore not the doubler. So this must be the doubler, which means this can't be the doubler, which means this is the doubler here. So this is an 8. This is a 9 doubled. This is a 6. This becomes a 3, which makes this a 4. This is a 7. So 4, 5, 6, 7, 8 as the Renban, which works. This can't be 4 or 9 here in column 8. So this must be 2, which makes that a 4, which makes that a 9. This 7 means this can't be 7, so this is 2. This can't be 3, so this must be 7. This can't be 2 or 7, so it's 3. This 4 makes that a 5, which makes that a 4. It also makes that a 6, which makes that a 4. This 7 means this is a 6. This 5 means this is a 7, and which makes that a 5. And that's the solution. Apologies for that mistake here. I really don't know why I had a 3 there. That was weird. Yeah, aside from that, flowed pretty well. I just didn't, it was just that major mistake there. This was interesting, though, how this was restricted. I was having problems in it when I messed up the Renban here. But once I got the correct digit here, then everything flowed pretty well from this one, right? Because we had to have a 9 here, because there's no other way to get an odd digit here. So we had to have the double actually be there. Then this had to be a 9, because this could not be 4 and still actually function well. Yeah, and therefore that makes this 4, which meant this couldn't be the doubler, which forced that to be the doubler, which actually restricted things even more. Pretty cool logic. I just wish I hadn't messed up this part of the Renban here. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.